Lesson 1.1 is on variables and expressions. The objective for today, to write and evaluate an algebraic expression given a word problem. And what I want you to do, sort of as a warm-up to this lesson, is to come up with words, other words that mean the same thing as addition, subtraction, multiplication, and division, and go ahead and put them in that box. All right, so for example, another word for addition could be sum. So you'd put sum in there. So go ahead and do that. See how many you can come up with for each. Go ahead and pause the video, and when you're done, go ahead and hit play again. Okay, so here's the list that I came up with for addition. I wrote increased by, more than, sum, and plus. So those all mean addition. For subtraction, decreased by, minus, less than, difference between, fewer than. Multiplication, of, times, each, product of, and then twice, triple, quadruple, etc. And then division, per, quotient of, and ratio of. Okay, and so those are just the basic ones that you want to have written down. Okay, before we get to the first problem, I want you to copy down these 3 steps for writing algebraic expressions. Alright, so when we get a problem like the one we're about to see, we're going to first look for keywords that suggest operations. Alright, so those keywords are the same words that we just brainstormed in our opening activity. The second thing was we're going to define the variable, and then finally we're going to write the expression. So go ahead and write these 3 things down on your guided notes, and we'll get started here in a minute. Okay, so the word problem of the day. While on vacation, you rent a bicycle. You pay $9 for each hour you use it. It costs $5 to rent a helmet while you use the bike. So in A, we want to write a rule in words. Alright, let me get the pen up here. So before we write the rule in words, what we're going to do is follow our 3-step process. Alright, so we're going to look for keywords that would suggest operations being used. So the one thing that jumps out right away, and we jotted this down to mean multiplication, is the word each. Remember, each was a word that meant multiplication. Alright, so you pay $9 for each hour you use it. Okay, it costs $5 to rent a helmet while you use the bicycle. Alright, so each is really the only keyword that we see. Alright, our variable, h or hours is going to be our variable. So let's define h as number of hours, because how much I have to pay depends on the total number of hours. Alright, so that's what's going to change potentially. Alright, so that'll be our variable. So let's write the rule in words. So we have 9, and then for each, so 9 times, alright, each means times, so 9 times h, so hour is represented by our variable h, so 9 times h. Right, and then it says it costs $5 to rent a helmet while you use the bicycle. So no matter how long you rent the bike, alright, you're paying $5 for the helmet. Alright, so that is like your flat fee. So that does not change based on the number of hours. So we are then just going to add, or we're doing this in words, so we're going to say plus 5. All right. Now, write the rule as an algebraic expression. So 9 times h. So we can write 9 times h as 9h plus 5. Okay, and there's our expression. Can you write this in other ways? Absolutely. You can flip it and say 5 plus 9h. So you have a $5 helmet rental fee, plus you have to pay $9 per hour for the bike. All right, so we're going to go ahead and use this one. All right, so we're going to complete now the table. So the number of hours, 1, we're going to plug into the rental cost expression. So this is going to be 5 plus 9 times the number of hours is 1, so we're going to plug that in. And then 5 plus 9 times 2. 5 plus 9 times 3. And then 5 plus 9h, that was our expression. So let's evaluate this. So 9 times 1 is 9 plus 5, that's going to give us 14. So you got to pay $14 for 1 hour of use for the bike. For 2 hours you're going to have to pay 18 and 5, so that's going to be 23. And then for 3 hours, that's going to be 27 plus 5. That's going to give us $32. All right, so it's problems like these that are going to be the focus of today's lesson. Okay, for the individual problem-solving problem, we're going to go ahead and do this together. So a state park charges a $20 entrance fee plus $18 for each night of camping. Write a rule in words. All right, so before we begin all this, what's our 3-step process? First is to look at words that would suggest operations. So I see 2 right off the get-go. I see plus, which was mean addition, and each, which would be multiplication. All right, now we have to define our variable. So a state park charges a $20 entrance fee plus $18 for each night of camping. All right, so we're going to let n equal the number of nights. Oops. Okay, so n is going to be our variable. So again, how did I know the number of nights is my variable? Because my total fee depends on how many nights I stay, and that number of nights can vary. Alright, now let's write a rule in words. So we're going to say 20. So a park charges a $20 entrance fee. So that is your kind of your flat cost. That's what you're paying up front. So we're going to say 20, and then plus $18 times, n. So there's our rule in words. Let's convert that to an algebraic expression. So 20 plus 18n. And we can write that as 18n plus 20 if we choose. All right, I always like to put the flat fee in problems like this up front. So let's complete the table below. So how much is your fee if you stay for a night? So it's going to be 20 plus 18 times 1. All right, so that's going to be $38. For 2 nights, 20 plus 18 times 2. So that's going to be 36 plus 20. That's going to be $56. And then 20 plus 18 times 3. That's going to be 54 plus 20. That's going to be $74. And then our expression from above was 20 plus 18n. Okay, what I want you to do on your own right now is to write a similar problem to 1 and 2 that you may have countered this summer. So create a table like the previous ones to show off your problem above. So you're basically recreating 1 and 2 with your own example. So make sure you do that. You can pause it, but you need to do this one on your own right now. Okay, the group extension problem. So the table at the right shows the number of bagels a shop gives you per baker's dozen. Write an algebraic expression that gives the rule for finding the number of bagels in any number b of baker's dozens. So b is our variable. It equals the number of baker's dozens. All right, it tells us. That's how we're defining b. Okay, so let's look at the pattern. So we see 1 baker's dozen gives us 13 bagels. 2 baker's dozens gives us 26. 3 gives us 39. So what's going on here? Well, it looks like in each of these we're multiplying the baker's dozens, the number of baker's dozens, by 13 to get the total number of bagels. All right, so that's the pattern. All right, so the number of baker's dozen is multiplied by 13. All right, now how can we express this mathematically? So the number of baker's dozens right here, what does that represent? B. Okay, so, and then what are we doing with B? We're multiplying it by 13. So 13b is going to be your expression. All right, so let's just say you were given 10 baker's dozens. How many bagels would that be? 13 times 10 would give you 130. Okay, and I want to end by writing an algebraic expression for each word phrase. And this, we were doing this, in the examples above, but sometimes some of these can be tricky, especially subtraction, and we'll see that in B but let's do A first. So the product of 2 and a number. All right, so we're looking for keywords that would indicate or suggest an operation. So product. So when we see product, we're thinking multiplication. So what are we multiplying here? We're multiplying 2 and a number. So a number would be our variable, so we're going to call that n. So the product of, so we're going to multiply 2 and a number. So 2 times n, or 2n, is how we would write out A. Now, we have, the next one is 5 less than a number. So less than would indicate subtraction. Now, you may be tempted to do, okay, 5 minus, and then a number n. And that would be incorrect. Right? What we want here, you have to really pay attention to subtraction. So we want 5 less than a number. So we need to put the n up front minus 5. So this would indicate 5 less than a number. So be careful with subtraction. Alright, and again, this is not the same as what we just said. It's not the same as 5 minus a number. 5 minus a number you could just write as 5 minus n. Okay. Alright, and then for part C, we have 8 times the sum, which is addition, a number, and 12. So a number, we'll use n and 12. So let's write this as 8 and then times. So we're going to have to use parentheses here. So 8 times, what are we multiplying 8 by? Well, we're multiplying 8 by the sum of a number and 12. So n plus 12. Okay. Alright, so that wraps up the first lesson. Make sure you got all the guided notes copied down and you did the example problem 3 where you had to create your own example. Make sure that's complete. See you guys tomorrow.